section 3 under unit 2, reactions of naphthalene. At the end of this session, you should be able to provide products formed when naphthalene is treated with different reducing agents. Write at least 2 oxidation reactions for naphthalene. Describe how electrophilic substitution reaction takes place in naphthalene. And lastly, explain why electrophilic substitution reactions in naphthalene occur at a particular site. So naphthalene undergoes oxidation or reduction more readily than benzene. You need to keep that in mind. This is because reactions occur at one ring with one or more benzenoid ring intact with less energy needed to overcome aromatic character of a single ring than in benzene. So basically, naphthalene, which is formed by the fusion of 2 benzene rings, is supposed to have 6 pi electrons for one benzene ring, 6 pi electrons for the second benzene ring. So being fused together is supposed to actually have 12 pi electrons. However, that is not the case. Naphthalene actually has 10 pi electrons. So as opposed to its preferred 12 pi electrons that you're supposed to have, now it has 10 pi electrons. So that kind of decreases its stability and therefore makes it more reactive towards oxidation or reduction reagents. So this means that naphthalene has less aromatic stability than 2 isolated benzene rings would have. So in the reduction of naphthalene, depending on the reducing agent being used, it will lead to the formation of different products. So if you use sodium in ethanol and you reflux this at 70 degrees Celsius, you form this structure where one of the double bond has been reduced. In the same refluxing at 132 degrees Celsius, you end up removing 2 of the alkene functional groups. Now, refluxing at 150 degrees Celsius with hydrogen gas or platinum or nickel will lead to the formation of this structure. And finally, decalin can be formed with hydrogen gas or platinum or nickel at 200 degrees Celsius reflux. Now, in the formation of decalin, 2 different geometrical isomers can be formed, the cis or the trans. So if the reflux occurs at 185 degrees Celsius, the trans, which is the most stable, is formed. However, the cis is formed when the reflux occurs at 193 degrees Celsius. So with nickel catalyst, the more stable isomer is produced in large amounts. With platinum as the catalyst, the less stable isomer is produced in large amounts. So similarly, in the oxidation of naphthalene, different products are formed as a result of different oxidizing agents being used. So we can form the 1,4-naphthoquinone or this dicarboxylic benzene structure, or this structure as well, or this diketone benzene structure, which is phenaldehyde. So depending on the oxidizing agent or reducing agent being used in the reaction of naphthalene, different chemical products can be formed. Now, benzene, naphthalene, just like benzene, typically undergoes electrophilic substitution reaction because it's an aromatic compound. It undergoes electrophilic substitution reaction. Now, nitration and halogenation of naphthalene takes place almost exclusively in the alpha position. That's position 1. And this is because it is only at this position that the most stable intermediate carbonium anion is formed. So the carbonium anion is, let's look at the carbonium anion that is formed in the slide. So the carbonium anion or ion that is formed in these 2 cases, at position 1 and at position 2. So if the electrophile is attached to the alpha position, which is the position 1, the anion or the ion that is produced, the carbonium ion that is produced, look at this, out of these 4, this 1 and 2 have the benzenoid structure intact. However, this and that do not have the benzenoid structure intact, which makes these products more stable. The attack at carbon number 1 more stable than the attack at carbon number 2. Now, if you look at attack at carbon number 2, only one product is formed with the benzene ring intact. All the other three do not have the benzene ring intact. So it means that the attack at carbon number 1 allows phenolphthalein to form more stable products as compared to attack at carbon number 2.